Hello, this is your teacher Adam Billman again, and I'm now teaching you how to do a chi-square test for independence. As I said, there are two types of chi-square, the first one being a chi-square goodness of fit, and this one is a chi-square test for independence. The basic idea of a chi-square test for independence is that we usually have two variables. In this particular case, we're going to be having gender and the major that they have in college, and we're trying to determine whether or not there is some sort of relationship between the two. That is to say that, let's say, males tend to be more likely to pick math than females, or something of that sort. The idea being that this category affects this category. So generally speaking, in order to do this, we have to first, of course, as the previous one, we have to build our observed table and our expected table. You notice that this time we actually have two different tables instead of just one table. And the reason is because this is a much more complex system. First, I need to determine the total for every single one of these groups. And then I have to, using those totals and those percentages, then determine how many should have been in each one, assuming that there is no relationship. So I'm going to show you how that's done. First, let's get our totals. And this is not a difficult task. Once again, I'm going to just tell it to sum these numbers together. I'm going to have it do it for every one of my columns here. Sorry, rows, I mean. Do the exact same thing here. So sum of all of these. And of course, have it do the same thing over here. Boom. So now we have our totals, and once you have these totals, we then need to determine what the percentages are for each group. That is to say, what is the percentage likelihood that someone would be male versus female, that someone would be in math or biology and so on. And we base this entirely on the total for the entire thing. Now remember, we need to sum this. We don't need to sum all of them. We just need to sum one of these. And this will give me the total number of people, which is unsurprisingly 180, since 100 plus 80 is 180. Notice that it doesn't matter if you add these or these, you'll get the same number. Don't add both, or else you'll end up with twice your number, and we don't want that. Now, here comes the next part. We need to determine the probability that someone would be male, so we can use this to eventually build our center. Now, this is not a difficult task. What we do is we simply take the number of male, and then we're going to divide it by the total number. Once we have that, boom, there's our probability. And the task for female is done similarly. I simply take the number of females, and I divide it by the total. Boom, there's my number. Once again, this should add up to 1, since this is a probability. We can, of course, do the exact same thing here. I'm going to use a nice little shortcut to make this quicker. What I'm going to do is I'm going to click here, tell it to divide by that number. I'm going to tell it to not change that number, so that I can just copy and paste this all the way down without having to do this manually one by one, and boom, now I have all of my probabilities there, my probabilities here. Notice that this makes these part of a frequency table, and that's because this is almost a frequency table. I say almost because the interior of these is going to be made by multiplying the column and row that they're associated with times the number of people, which in this case is 180. This shouldn't be a difficult task. All I have to do is legitimately just tell it to take the probability that they're in this column, boom, and just make sure that we can do this quickly. I'll tell it never to change this. And I'm going to tell it to multiply that by the number in this row, and finally by the total number of people, which I'll also tell it once again, do not change this. That little $sign just literally means don't change the number. I do not want it to change the number. I want to be able to just copy straight down. Because as long as it's copied down, then I legitimately have all of these things done correctly. And these are the expected. So keep in mind that how each of these are made. So if you were doing this by hand, what you would do is you would say, for this number, I would multiply it by 0.444 repeating, and 0.1944 repeating, and then multiply it as well by the number of people you have, which is 180. The idea being that this will give me the fraction I should expect here, given this probability and this probability. So you'll notice that this is actually kind of similar to what we did over here for the original, except that here we have two probabilities multiplying instead of just one. That's the only real difference between the two. We'll do the same thing for female. So once again, it's going to be testing yourself. Yes, hopefully you just said this probability, the probability being female, times the probability of being in math. And then finally, times the total number of people. Setting it up so that these don't change once again, because I do not want to have to type this in over and over again. Enter. Copy down. So of course you'll notice these numbers do not perfectly match up, but whereas this one was vastly different and obviously wrong, this one is not as clearly wrong. The numbers are different, but some of them are pretty darn close. So if I saw these, I would not be able to tell from these alone whether or not this was a significant difference. But the good news is we have a calculator for this. So now we're going to finally get into our calculator. And this is where it's going to get a bit more difficult. Because reality is this math here is all set up, but it's a pretty simple idea. Just the percentage of people who are in math, biology, psychology, and so on. Some percentage of people who are male, female, and to get the numbers, you just multiply the probabilities times the total. That's not a difficult task. You've done this before, and with a little bit of practice, you could do it yourself. However, this, using the calculator, is going to be a bit more tricky process because we have to get these two tables in. And for this, we're going to need what are called matrix operations. Now, to get the matrix operations, we're going to have to use a special feature you might not be aware of. If we press alpha and then the zoom button, we will get this weird looking screen. Now this weird looking screen just allows me to make what's called a matrix. Now this matrix is going to have two columns, one for male, one for female, and it's going to have 4 rows because we have math, biology, psychology, and sociology. And so this is what we're looking for. You'll notice it's already set up that way. I try to test this stuff out in advance. What I'm going to do is I'm just going to go ahead and say, okay, press enter. And now, once I press enter, it wants me to type in my numbers. Well, first we're going to do the observed values. So I'm going to type in my observed values. We'll do the males first. So that'd be 18, 27, 16, 19. And for my second column, I'm going to type in 17, 30, 28, 25. Now, once I've typed these in, I still have one more thing to do. I need to store this somewhere for later use. So I'm going to actually press the little button. We haven't used it very often, but it's the STO button, or store button. It's right above your on button. If you press this, you get a little arrow. And this is still not enough. We have to do one more thing. I need to get to this matrix section. So I'm going to press second, and this little not inverse x, but reciprocal of x. And that gives me this. What I'm going to do is I'm going to tell it to replace A. So I'm going to literally press enter. And what I'm telling it right now to take this matrix, store it into A, and that's the entire operation. We're done. Now we have to repeat the same operation for the expected. So alpha, zoom, there's my matrix, enter. This right here, I'm going to input with my predicted values. We'll round these numbers a bit. So 15.56, we'll do 2 digits. 25.33, 19.56, and 19.56. Doing the exact same thing. Make sure, by the way, that when you're typing these in, that the number is what's highlighted and not a little arrow on the side. Some calculators will have a little arrow. If yours does not, then make sure you have it in this manner. 19.44, 31.67, 24.44, and 24.44. With all of this in there, I now once again store, and this time I need a different matrix, so I'm going to go back to my matrix bit. I'm going to tell it I want to store it in B this time, because I want to have two matrices, one which we'll call A, one which we'll call B, and the whole purpose behind getting these two matrices is now I can click on Stat, go back to my tests, go to chi-square this time, because the chi-square test itself is listed as chi-square by itself. I'm going to press Enter. My observed are in A, my expected are in B, so we're pretty much already done there. Press Calculate, and boom. Notice that this time it actually calculates degrees of freedom for you. You do not need to do that yourself. I do have a chi-square value of 2.08, but my probability, if you look right here, is 0.55. So there's roughly 55% chance that this would have happened by random chance. So does there appear to be a difference between males and females based on our data? No, there probably really isn't a difference, or at least not based on this data. Perhaps with other data, or perhaps with different things, we might find something, but at least based on this data, we don't really have any evidence that there's a difference. So this is the basic idea for how to run a chi-square. I hope that I found that this finds you well, and I shall see you when all of this quarantine stuff ends.